Hello my friends, welcome to Incidental Electronic channel. This is Uncle Misha. Today we are trying to disassemble Neewer LED light model NL660. So always curious what's inside, so stay tuned and we're gonna do it together. So in order to take it apart, we need to unscrew a few screws around here. And I'm not sure if we need to unscrew here, and they look like they are hex something. So let's try this screwdriver. This is H2.5. Yes, they are. I'm gonna turn this down. Alright. Looks like this module gonna come out a whole a piece. As simple as it is. So we have just a module right here. In order to remove this module, I definitely need to I think, pull these guys. Maybe even, but I think we will have to, do this. Okay, so let's, this time it's, these are silicone wires, no joke here. Looks like in order to get to the LED panel, I would have to take apart this thing. Not sure if I have to, but let's see. Now we need regular screwdriver, like a Phillips. It's too big. Any other Phillips I have here? Let's take my favorite Phillips. I'm a VHF fanboy. Few more screws around here, and what do we have? Okie dokie. We have tiny capacitor. We have barrel connector for the power supply, LED, 2 inductors. So this is constant current, supposed to be constant current, the driver, and this is controller. Curious to see. Let me see a little bit up close. What do we have here? Let's put those screws together. Okay, here we are. So I did some decoding right here, and this is what we have. So little cheat sheet right here. So over here we have the big ass chip. Let me use another pointy thingy. So this guy is some sort of microcontroller, because all these potentiometers connected to it, and this 4 is quite suspicious that this is probably RX serial. Then we have those, over here there is a voltage regulator, obviously, to power the microcontroller from 12 volt or something to this extent, of 15 volt, make it 5. So this is 5 volt regulator. It is 6228A voltage regulator. So then we have those 2 transistors. They are N-channel power MOSFETs. They are driving part of the driving circuit of the LED. So this is supposed to be constant current, and the voltage, we have to take a look what the voltage is. There is 2 little teeny guys right here. I believe these are drivers, XD8021. No information about those guys. Have no idea what are those. So next step, what we're gonna do, I'm gonna check voltages. So here's my multimeters, put DC on, right, and we're gonna use batteries. It's like way less hassle. So I do believe, because of that many LEDs, that's gonna be driven by some kind of higher voltage. Do we have light? No light. Do we have light? No light. No light. Oh, okay, I know light because we have light now. Okay, so let me check some voltages here. Oh, we have actually markings here. BA, B minus, B plus. Let's see what is B minus, B plus. 5 volts. What is A minus, A plus? 5 volts. Interesting. So obviously it's not the voltage what's changes the brightness of LEDs. It's current, because those potentiometers, they are adjusting the current, not the voltage. So in order to understand what kind of current we're talking about here, let me actually measure straight on this. All right here. Let's just crank it up maximum. And let's just check voltages. Okay. Obviously the 3 wires are coming in because there are 2 different colors. So 5 volts. Now I'm actually curious. So I'm curious that I thought this is gonna be like a boost circuit or something, but no, turned out to be they just constant current voltage regulation. Sorry, constant current regulation drivers right here. They are not getting hot, but the traces are pretty thick. Okay, let me crank all this. This inductor is a little warm. Everything else is barely warm to the touch. Yeah. So now we're cranking up the maximum current. So what I'm gonna do, I'm gonna measure the current right on here on these wires. I'm just curious what are we running. Also, I'm curious to open up this panel to see what's going on inside. So let's just open up the panel now. Let's just remove these batteries and see. I'm gonna remove this too. And then, this hardware can just stay to the side. Okay, let's open. Now, where's my... Be curious to see. Also would like to know what's the current actually flowing through this thing. Because I want to calculate them, knowing the number of LEDs, to understand also the if I can actually crank it up. You know, because I probably can modify some resistors in order to get higher current. Huh. I have a sneaky suspicion that I would have to desolder these things in order to pull the panel out. So this is how it looks like. But I believe I won't be able to pull it out because I need to unsolder these wires. Good guess. So we would have to... Yeah, it actually slides out either one way or another. Clearly the panel slides out. I just need to deal with these wires. So definitely have to pull soldering iron and get unsoldering. Okay, that was easy. That was easy too. That was easy too. Alright, that wasn't bad. Now we can pull these guys out. Not sure which way will be easier. Ta-da! Okay, so here's our LED matrix. It contains 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Looks like we have 22 by 30. Alright friends, so what are you gonna do now? I'd like to actually solder things back and measure some current. So we have voltage between these two guys and these two guys. So this is like two grounds, and this is a plus. So right, I'm gonna be soldering. So here our plus, here our two grounds. I'm gonna be soldering them back, but not necessarily everything gonna be soldered back. Alrighty, so I have soldered those two and soldered a little piece of wire over here when I'm gonna connect ampere meter right here. Alright, so we have alligator clips. This goes here, this goes here. First I'm gonna switch to amps. Okie dokie, then just put some batteries back. I'm gonna use batteries. And let's just turn it on. And what do we have? We have 5 amps! Polarity. So when everything is cranked, we have what we have when we have lowest. We have 0 amps. That's cool. It's half of it. And now it's another half. So yeah, we have 5 amps and voltage. I need another multimeter. I'm just curious what the voltage is. We have VDC. I wish I have like dual multimeter which can do. I think this guy can do dual. Huh? Can you? No, it doesn't. It can't. Never mind. I know what I'm talking about. 6.8 volt. I'm wondering why. Interesting. I need to double check what's going on here. Okay, but this is our panel. Super bright, obviously. Oh my god, this is like crazy bright. So yeah, here we are. It goes 5 amp. Okay, 6 volts. So another very interesting thing I just investigated. So here's our LED panel, and I'm gonna zoom in. So here's our LED panel. So arrangement of LEDs is like this. So every 2 LEDs are connected together. So this LED is in series with this LED. This LED with this LED. So essentially what we have? We have over here we have 6 volts. It'll be hard to show you, but here's the multimeter. I can't. That's too. So, but between those two we have 6 volts. Or whatever left after running over the wires. You have 5.3 volts on LEDs, right? 5.3 volts. So this is essentially means that those two LEDs are splitting the splitting the voltage applied because they are in parallel. Sorry, they are in series. So 2 LEDs are in series. So that's why we have 6 volts and input in here because of the wires, because of these wires. We are losing some current. This means that these 2 white LEDs running at roughly 2.5 volts or 2.6 volts. We can bump it up a little bit higher. So this is my idea. The reason I wanted to take this apart to see if I can actually adjust the constant current regulator over there to run at higher voltage, and our supply higher current here. But that's need to figure out the schematic of this. But so far we have 5 amp, and these LEDs at 5 amps, they are barely warm. So like super barely warm. So yeah, so totally can actually push them a little bit further and increase the light output. So when we measure the voltage, alright, so when we measure the voltage, here is my voltmeter. So on LEDs, right here we got 5.3. Here on input we get, so there is some kind of obviously loss here. And what about this between these two? Yeah, so there is a loss obviously. So we have to measure right here on LEDs. Oops, they just shorted. Yeah, you see what I've done? I just shorted these two accidentally, and one LED started obviously running brighter because the current increased. So yeah, so over here we have 5.3, we have 5 amps right here. So we essentially this thing runs and 5 multiplied by 5.3 equal 26 watts, 26 and a half watts. So, or measured 5.09 multiply by 5.3, 27 watts. All right, we have 27 watts. So this is, but it in spec it says 40. So I assume we can push this whole thing higher, right? Well, it's getting warmer, yeah, but still. All right, so this is my idea here. So I'd like to figure out the driver over here, driver circuitry, and actually try to run all this contraption higher. But that's gonna be next video. At least I know how it works, and at least I know what component to look for. Okay. Oh, looks like the wires that are running 5 amps, no big deal. Anyways, so this is gonna be my task. But for now, I'm gonna put it all together and just start using it. But when I have time, I know the schematic. I actually took a picture of all this layout, and I will be thinking how can I increase the current that drive this LED panel. All right. So guys, let me put it all together, and we're gonna be wrapping up. Curious. This thing got warm actually. Whoa. Yeah, 5 amps, and this guy, what kind of? It's supposed to work for 10 amps. Whatever. Okay, finally I put this thing together. Fiddling with wire was a bit of a challenge, had to kind of fish them through, but it's all doable and possible. And here is our test. Alright, so let's see some light. We have some light, it's working. And obviously, let me see if it properly adjusts the light. Yeah, it does. Okay. So we learned something today that we totally can, I think, hack this thing to, when we need it. I need to also figure out the components we actually use there, because there was not some of the things is not obvious. But it's the first step. So also what was good to actually see the voltage and the current consumption of that LED panel. So yeah, here we are. So that was teardown of Neewer LED light model NL660. Also it says, warning, do not disassemble the product without authorization. Yeah, right, I need to ask someone, of course. Here we are. Guys, please stay tuned for more videos like that, teardowns and some projects and some repairs. Stay safe, stay tuned, and ciao.